Well, this is Jack Jackson. In this video, we're going to be talking about differentiability and continuity. Specifically, we're going to be looking at this question: does continuity imply differentiability? In other words, if a function is continuous at a point, does it have to be differentiable at that point? We're going to see if we can understand that and get a answer to that question. Now, I'm using a GeoGebra app that I wrote, and this is available at the GeoGebra site. And so let's look here at the function. So this one has 4 choices of functions. And say if I start with this one here, all 4 of these functions are continuous everywhere. So notice this is all one connected piece. The blue graph is the actual function. Actually, the formula of it's here. F of x equals absolute value of 4 minus x squared. Close absolute value. And our point of interest is this point C, which is the point 2, 0. And we can look at secant lines as we take a well, it doesn't have to be nearby, but just another point on the graph. And of course, when we have the slope of that secant line, then is a difference quotient. And if we take the limit of that difference quotient as the h, or delta x, approaches 0, we're basically letting the d get close to the c. And so we can see what happens here. You can see the slope of the line down here. And look what happens as it gets closer and closer here. Okay, it looks like it's maybe coming in on some kind of number. Looks like we have a tangent line that it's approaching from that side, but it looks like it has a negative slope, maybe -4, possibly. But look what happens on this side. As we come in from this side, we're also approaching a different tangent line, in this case one with a positive slope. Looks like +4 for that slope. So we have 2 completely different looking tangent lines that would be, sort of candidates for that limit. Well, actually it turns out that that left limit is approaching, left limit of the difference quotient is approaching -4, and the right limit is approaching +4. Since those left and right limits do not exist, or are not the same, they exist, but they're not the same, then the full limit does not exist. And so the derivative is actually undefined there. So the answer to our question, we know, we could have a function that's continuous there, but it's not differentiable. And one of the reasons, there's actually a couple different ways this could happen. One is when we have a sharp corner. So this one's also not differentiable here at x equals -2. The easiest example that we can look at for one that has this problem is just y equals absolute value of x. And you can see that when we're to the right here, the derivative is 1, and the left, the derivative is -1. There is another type of problem that can happen, and it's illustrated here with this function, f of x equals x to the 1/3 power, or in other words, the cube root of x. And this is continuous anywhere, everywhere, again. And the interesting point here is at the origin. We take another point on the graph and we look at the secant lines, and we see that as these points approach, they are approaching a legitimate tangent line. But that tangent line is what? Is vertical. Well, what's the problem with that? A vertical line does not have a slope. So if we look at it, actually, whether we're coming from the left or the right, in this particular case, the slope is approaching, the difference quotient is approaching positive infinity. So that means the derivative is undefined there. Here's another example with a vertical tangent line. From one side, they're approaching -infinity, and the other side is approaching positive infinity when we do the limit of the difference quotient that defines the derivative. We do have a legitimate tangent line. It's vertical. The slope is undefined. So the two things that could happen, you could have a legitimate tangent line. The secant lines are approaching a legitimate tangent line, one single one, but it's a vertical line. Or you can also have one that's approaching two different tangent lines, one from each side, or some other way is not approaching a single tangent line. Then that would be something where the derivative is undefined. So bottom line is you could have a function that's continuous at a point, but it's not differentiable there.